Welcome. In this video, we're going to look at iptables. Iptables is a mechanism for manipulating the firewall that's built into Linux. So this is an example of host-based intrusion detection or protection in this case. And iptables comes with basically every Linux device out there. And so it's built into lots of routers and embedded devices and stuff of that sort. So we're going to go over some of the basic commands associated with it. And the first thing to look at is that there's chains. So for this example, I'm going to use the security onion distribution. Again, this comes with every Linux out there, so you can use whichever one you want. Manipulating the firewall is a privileged action. So rather than typing sudo all the time, I'm just going to run all these things in a root shell. And to get started, the simplest thing to do is just to list out what's there. And if you look at what's listed, we see 3 chains. And a chain is just a set of rules that we're going to apply to all the packets. And these 3 chains are input, packets that are coming to the machine, output, packets that are leaving the machine, and forward. We're not going to look at forward that much, but if you think about, intermediate routers on the internet, many of them are going to be running Linux. And for those types of machines, the forward chain would be more interesting or useful. So one other thing I'll point out here is that we're going to have a list of rules. So like say I have iptables and I want to insert something to the input chain, and I want to say that maybe the destination something like this. So I've added a rule, and this rule says if the destination of this incoming packet is this address, then I want to drop it. And if I do my listing again, I see that rule is there. Right. And you notice the listing also has a source. So if I wanted to change that and say that I want this rule to apply for the source, then I'm going to list it again. And I have for the source and destination, right? And I could, of course, specify both of these. And I'm going to change the second one a little bit. Right. Now, one thing you'll notice is, so the -I here is for insert. If I use a -A, that would stand for append. And that just affects, so I'll change this so we can see it easier. That affects where the rules show up in the list. So the order I put these in, I put this one in, and then that one. So when you do an insert, it goes at the front of the list, and when you do a append, it goes at the end of the list. The ordering matters because it will, as it compares packets, it'll go through until it finds a match, and then after it finds a match, it applies the target or the kind of the action that we're going to do. And for all of these, we were dropping the packets. We could also say, so like if I added another rule, except, this rule here would never get triggered because it would match on this one first, and then it would never take a look at this rule at all. And similarly, if I had done an insert for that, it would put that at the front of the list, and then neither of these would have taken place, right? So the ordering matters. You can, decide which specific place you want to put them in. So let's take a look at the man page for a second, right? So after I say the insert, I can give it a number or a position that I want it to show up at. And I could do that with both the insert or the append action. Actually, the append just is at the end. So for the insert, say I want to put this in the middle, so like 4, and let's change it so it's easier to see. So I'm using IP4 addresses. You can use IP6 also, but okay. And so we put it in the middle by giving it a position number. So that's the basic idea between, we can insert things. It is also possible to drop things, remove specific rules. You can also, if I do a capital F, I can flush the table, and then that empties it out altogether. In general, you're not going to be using iptables manually. Probably what you'd want to do is have some sort of script or software that's managing how this access control rules are being put in. So a lot of times the most reasonable thing to do would be to have the script flush the old state out and then reinsert all the new rules in there to make sure that it, just for simplicity's sake. So that's kind of the idea behind chains and listing and flushing. Let's talk a little bit more about the rules themselves. So and what I'm going to do is I'm going to use the program called netcat. Let's do that man page. So netcat is, you can use that to do to create network connections. So for example, so I have two terminals here. If I do a netcat and I do a listen on port 500, okay, it's not doing anything. But if I do a netcat and I connect, right, so nothing's been sent yet, but if I hit enter, right, so I have it's just a simple way to test out a network connection. So let's say I want to set up iptables to block this connection. So I can give it a port number. So I'm going to say iptables. I want to insert a rule on the input table, and I want to, for the protocol TCP, I want to block port 500. And let me double check on the syntax. so we're going to do P for protocol, TCP, and for the port number, there you go. Okay, so we want to block port 500. So we're going to add a rule to iptables. We're going to insert into the input chain, and we're going to say we're going to do this on the TCP protocol, and we're going to say destination port 500, and we're going to drop that packet. Now, one thing to be aware of, if we look at the iptables man page, there's no destination port here. And the reason that is we need to look at the iptables extensions. Essentially, all the protocols have their own different rules associated with them. And since ports are actually part of the transport layer, if we want to look at that, then we would have to go up to the extensions. So a lot of these are in extensions. Anyways, going back to, let's look at this. So we're going to drop anything that's so this is 500 is some protocol for ISA Kemp, it looks like. If I test out, if I do the same netcat I did before, okay. Right. So it's not doing anything. So the drop action does not send any reply, it just throws the packet away. And so the sender in general doesn't know that it's been thrown away. It just thinks that it was sent correctly. If I flush out that rule and I replace it with a reject instead of a drop, okay, so I have reject now. So if I do my listen, and then if I try connect, it just returns. And if I were to do like a verbose, oops, it's going to give me the error message that the connection was refused. So it never gets there. So that's just one way to see that's working. We can also filter on the source port and on the destination and all those options. So the common ones that we might do. So let me add the source port. It'd be pretty similar. It's just instead of D we say S. Okay. And right, so we can read those and see that there. Again, source and destination are pretty common options, and the simplest thing is just to specify specific IP addresses. You can also specify a subnet or a range. So let's look at the So these have been on the input. I could also do it on the output. So I'm going to flush it, and let's put that same rule on the output table. Try that. So I'll do the listen here, and now if I try to connect, okay, again I get a connection failed, and that's because I'm trying to connect out to that other port. And again, if I changed it so that it was a drop, it just would never show up at all. The extensions are useful and have a lot of neat features. Let's look at that man page again. One thing that you can do is you can look at the connections status, right? So on a connection per connection basis, you can say, how many bytes have been transferred on that connection. How many connections do you have between this server and client? Okay. And then another very useful one is the state. Right. So for connection state, we could, a lot of times you might say, I only want to allow new connections and established connections. So new connections, so you can start up one and then an established one. And so that'd be a pretty common thing that you might do. And again, here's there's the state. Okay, so let's take a look where we're at. Address. So I've been mainly using TCP as an example. UDP is also valid. The other action, right? So we looked at drop, we looked at reject. The other action is accept. And accept is basically you're whitelisting something, you're approving of something. So like let's say that you wanted to set up a whitelist so that you approved of everything from your local area network. So I could say something like, I want to approve all TCP connections that are have a source of 137.142.0.0, right? I want to accept all those. And so this is basically saying I'm only looking at the first part of the address to determine what to do with this. And again, if you want to have that apply for UDP also, you can. Right. So you can use iptables to set up a whitelist also. Now, one of the things that happens is that, again, as a packet gets evaluated, it goes through all these things, and then there's a default policy that gets used. Right now the default policy is accept. We could change that so the default policy what would be the drop. So, okay, so now this is kind of a pure whitelist in that I'm only accepting packets from my local area network and dropping all other input packets. I don't have any restrictions on the output or forward packets, just on the ones who's coming to my local machine. You do need to be a little bit careful about this because sometimes a lot of things run on the local interface, like different parts of the desktop environment and stuff will communicate using sockets. If we look at the interfaces, so this is a virtual machine, so this is kind of the virtual Ethernet interface, and then there's a local loopback device, right? And iptables can filter these also. In general, we wouldn't want to filter those. And so one thing you can do is you can also specify, so I'm going to change this back to accept for now. You can, in your rules, you can say which interface you want it to apply to. So if I want to apply to the Ethernet device, I would say the interface I in that device. Okay. Now, on this summary table, I don't see it, so I would probably need to use like a verbose mode. And then here I can see that it applies to that specific device. And you can do input devices and output devices. Okay. Okay, so those are the three main actions: accept, reject, and drop. The ordering matters, and again, extensions. There's a lot of things that will play out in terms of, you're going to need to look at the iptables extensions if you want to do more advanced things based on the protocol, right? Like for example, if we want to only allow kind of new SSH connections, say new SSH connections, right, so SSH runs on port 22, and we want to let's say limit them to our local area network. And we're going to check that the state it's either a new connection or it's an existing connection. Okay, and so that's this rule here. And then we could also, basically, the advantage of saying new and established is it rules out some different type of denial of service attacks. Okay. One other thing I think is useful to mention is, so we do have the ability to like specify different subnets in these rules, but sometimes services might be running on multiple machines, and you might not kind of know where something is going to be. In Linux, there's a etc hosts file, and you could, like, say I want to another way of doing blocking would be to kind of corrupt the DNS entries for different destinations. So if I wanted to block, say, Facebook, I might put some addresses for Facebook that where the connection would never work, essentially. Whether that works or not, whether modifying that works or not will depend a little bit on how your DNS is managed on your Linux machine. Okay. I also was going to do an example of how to translate kind of English rules or kind of English description of a policy into these different ones. Okay. So I have a script that generates some random requirements, and so I'm going. So, like, let's say I want to do these 10 requirements. Okay. So the first one, in the drop outgoing traffic, where the source port is 3390 for TCP and UDP. Okay. So to do that, okay, let's see where we're at. Okay. So I have all these except examples. I'm just going to get rid of all of that. And again, the first one is drop outgoing traffic, so I'm going to be using the output chain, and then the source port is the other piece of that. So TCP and the source port was 3390, I think. Oops. Sorry, cut and paste doesn't work so good with the virtual machine. And I think it was drop. Yep. Okay. And then I'm going to do the same for UDP. And so that's my first example there. For the second one, I want to make sure I accept incoming traffic for 10.0.14. Okay. Okay, so that's the second one. And then I want to reject incoming traffic with a source. I have a specific IP address and a range. So this isn't something that we've done so far. So let's look at how we do that. Okay. So the UDP protocol, the source was 105.20.41.109. And then I'm doing the range 590 or 59878 through 59883. And so I can do I use colon to describe the range. Oh, so the source port. Okay. Okay. And again, if I look at that, it's going to show the range. Okay. So let's see what else we have. I think the rest of these are all somewhat straightforward. This one's, again, I'll do the interface. And then the rest I think are all pretty straightforward. Okay. Outgoing traffic 24524. Now for outgoing traffic is -O. There's UDP and destination port of 24524. And we were accepting that. Okay, so and that rule is here. Okay, it's on this device, and we want the UDP protocol and that destination. So that's the basics of IP tables. It's it's pretty basic, pretty straightforward, but it's useful. And yeah, thank you, and have a good day.